I never do that. It's impossible mission. I can talk for days about this stuff. Okay, looks like actually people are coming live.
So let me just we are live. Let me
Our proven installation process ensures.
sorry. Welcome, everyone. Go ahead and get settled. We're going to get started in 1 minute. All right, there we go. Welcome, everyone, to GitOps. What is it and why do I care? We're going to be giving a technical talk today covering GitOps, and we will be able to answer all of your questions. I'm going to go over a few pieces of housekeeping before we get started, introduce you to our speaker. If you have any questions as we go along, please feel free to share them in the chat. There is also a ask a question button at the bottom of the screen. You can post your questions there, and we'll make sure to answer any questions as we go, and anything we don't get to, we can answer at the end of the session. So feel free to share where you're joining from. If you'd like to get better acquainted with myself and our speaker today and with each other, feel free to share in the chat your name and pronouns, your title and company, or maybe a program that you're currently pursuing, where you're joining from, or possibly during quarantine, or where you're from, something you love, and a quirk, so something that's uniquely weird or different about you. So I'll go first. My name is Jenna Ritten. I'm a cloud developer advocate at IBM. My pronouns are she, her. I'm currently joining from Western New York. I'm originally from Detroit. Something I love are my dogs. I have Yorkies. Hopefully they'll be quiet this time. They're usually scratching in the background. And something that's unique about me, I have an obsession for tuna salads and tuna sandwiches. If you've joined our sessions before, you're probably well aware. So I'd very much appreciate any recommendations for a great tuna sandwich if you want to share those in the chat. If you'd like to stay connected with me or follow any content, I have my handle for all socials, or my link tree as well if you need to get in contact with me. Our speaker today is Carlos Santana. I'm going to let him introduce himself to you, and then he's going to get started and do a talk today on GitOps, what it is, why you should care about it, why it's important for cloud native development. And I will be hanging out in the chat for all of you if you have any questions, so feel free to share in the chat. So Carlos, if you want to go ahead and introduce yourself.
Yeah, I'm Carlos Santana. I work at IBM, solutions architect for IBM Cloud, and working on hybrid cloud. Lately, I've been working a lot on Kubernetes, Openshift, cloud native technologies. And I've been doing some work around GitOps, and we found that it was going to be interesting to show some of those technologies and what do they mean, and if you have heard about them in blogs, I can help answer some of those questions about getting started and what it is. So happy to be here. I'm from Raleigh, North Carolina. Weather is awesome this time of the year.
Okay, very cool. Okay, so let me stop sharing so you can share your screen. There we go. Perfect. Okay, you go ahead. Go ahead and share.
Okay, so I think everybody sees my house here in Raleigh. I see people joining from LA. It's early over there. Texas, Michigan, Kenya. Wow, Texas, New York City, India, California. So I think we have a good crowd here. Let me share my screen so we can get started. I'll share my iPad here. If I can find my sharing screen. Oh, Greensboro. I have a neighbor here joining. And I will make this full screen. Do you see the slides?
Yep.
Okay. The slides are my iPad because I like to take notes and draw and scribble. I'm one of those students that when I took notes at school, I went back home and I couldn't read them. So if you're one like me when you were young, please put it in the chat. It was very funny. So what is GitOps? And then why do we care? I named this talk because I've seen a lot of I guess hype around people that I work with, or I work in open source. I also am a contributor for Knative. I'm the working lead for the user experience, and GitOps is also about user experience for developers and administrators and operators of cloud applications. And in this talk, I think everything that I will say, it could be applicable to any IT systems, but I'm going to concentrate just because of time, concentrating on Kubernetes and also on Openshift, which is a downstream, it's a distribution of Kubernetes that we offer in IBM Cloud and also on premises as part of our Red Hat that joined IBM. So on the next this is my Twitter handle. So if you look for Carlos Santana in IBM and you see a famous guitar player, do not follow him. Keep looking, and the next person probably is me. I'm from Puerto Rico also. I speak Spanish. And like I said, I work for IBM, and those are my LinkedIn and my GitHub. Don't worry, I'll share these slides when I'm done here on Twitter. So to get started, GitOps is part of CI/CD. This is another terminology that we find in when we're working with cloud systems and trying to deploy applications. People having problems? It says so trouble with the live stream and Crowdcast. Best. People are saying that Chrome works best. If you're having trouble, probably use Chrome. So we have CI/CD and CI/CD in terms of also DevOps, but CI/CD is continuous integration and continuous deployment. Right now, I've been for a few years. I was always been using continuous integration for doing the deployment part, but I think GitOps brings a very delineated aspect of it. But these are some examples of what is continuous integration, continuous deployment, and CI/CD. And sometimes you have seen continuous delivery. And so if you depend what blog or article you read, CD, continuous deployment, continuous delivery, sometimes get mixed up. Or even continuous release is also another terminology. at the end of the day, I would not worry that much what you name things, and concentrate more on the tasks. So these are the tasks that usually happen in continuous integration, and these are the tasks that happens in continuous deployment. For GitOps, we'll go more deeper into what deployment means in terms of being declarative. But for continuous integration, these are the type of things that you will do, things like compiling code, for compiling your Go code or compiling your Java code into jar files, linting your code, code analysis, code smells, security type of things, running tests. And running tests, I put very vaguely there because it could be unit tests, it could be integration tests to validate that this code is good to even before merging into Git, since if you use a source version control. Building images, and in Kubernetes, what we call images is container images. That's usually how we package our software. And producing artifacts. So producing an artifact could be producing a Helm chart that you run through a CI pipeline. And we have pipelines, and then code reviews also could be aspect of that. So that continuous integration, something that I call them imperative. Tools that you can use on these aspects are things like, in the past, I have used things like GitHub Actions, Travis, CodeFresh, GitLab pipelines, and recently one of the projects I contribute to is Tecton. It's from the CD Foundation, and also Tecton is an open source technology that we use in Openshift as an add-on called Openshift pipelines. Also, Jenkins is another one that is very famous on it. So this is the aspect of the app that you would do continuous integration. And then continuous deployment is rolling out your software. So rolling out a version of that image that you built, rolling back, doing blue-green deployments, A/B experiments, seeing if you're doing something like machine learning and detecting which one has more acceptance of it. Dealing with running tests, I have running tests also here, things like smoke test or health test if the version that is out is there. But most of these things can be declarative. You're not doing something imperative, you're declaring the state that you want to have. Running a task could be like you want the app to be healthy, or you want to meet a certain SLO, meaning a service level objective of like, you want your app to be fast, like less than 100 milliseconds for the 95th percentile. So you declare that in a format, and you save it, and then you let the system get to that desired state, however it needs to get to. So that's where I position GitOps into that. I'll go next to the kind of the official, not official, but in CNCF, I'm part of the GitOps working group. And we got together and we tried to define what is GitOps. And we defined them as a set of principles for operating and managing software system. And then when using GitOps, I already mentioned, is like the desired state that we want of that system or subsystem is defined declarative. And then it's version, meaning that you need to put it in some version control. And if you have something like Git, where you already know that every commit hash is immutable, right? For the most part, you should know that every commit is immutable. So that's the history and auditable information that is the data. And then the system that what you're trying to declare that state is the system configuration. So in our case, we're talking about Kubernetes, is you want an application with X amount of instances, configuration from it, access in terms of role bindings and RBAC. And the last point that is very important, continuously derive from this data. So you want to continuously make sure that the system state is the desired state. And that's something, if you have worked with Kubernetes, that's something that is very native to the way that Kubernetes work, is you declare the states inside Kubernetes. I'll go into that in a little bit. And then that if somebody changes by mistake or by error, it will fix itself. And these are some of the principles for that the working group got out of some discussions, a very high level, and more details are in the principles, and I have the links that you can get to it. So the first principle is that you want to have the state to be declarative. I think I thought a little bit of that. Immutable desired state versions, meaning that we can use source version control for that. Continuous state reconciliation. And I think this is the key aspect. Reconciliation is what makes GitOps a little bit different from other type of deployments that we have used in the past. Things like Terraform, Ansible, basic CI/CD scripts, or Jenkins that they don't reconcile. They push the configuration to the system, and then it's kind of push and forget. I'll go more details in that. In GitOps, there needs to be a reconciliation. Make sure that every X amount of time, or when it happens in events, that the desired state matches the desired state that usually you save in version control matches what is running in the system. So if for whatever reason, if it's software or humans change that state, the reconciliation will happen again, and then that state is stay there. And then the idea is operations through declaration. So this is more about the user experience for what I call some people call them operators. I don't like to use operator because I get confused about the human aspect. So is that human administrator that are trying to configure the system. They do it in the declarative way. So they're not programming. They're not creating for loops. They're not creating if statements. They're declaring the state of the system that they want, and that's a better user experience in terms when you scale to a very complex or large system, or multiple systems across different environments. So this is so the next one is, this is an example of, I call this one push and indent content. Ansible is a very famous one of it. Also, Terraform is also a very famous of implementing this aspect of that you declare usually in version control, and sometimes we most likely use Git, but you can use something else to store that state, that desired state. But in this case, I have an example here that I have a piece of software that it has a version 1.1 and maybe has a configuration of slow. And that's intended for environments that are for dev. And I have the same piece of software, and maybe there's a new version of it. And it's 1.1.2. Actually, I should have switched that 1.2. The newer version is in dev. So that's a typo. But the idea is that you declare this in prod, and you declare this in dev, and then you have scripts or the controller or the piece of software that will take this as input, and then it will run a script. It will be a Ansible script or a Terraform script or a Bash script, and then it will deploy the software to the intended environments. So you will get the version and the configuration that you want in different environments. And configuration could be, in Kubernetes, usually config map. It could be secrets, or it could be a type of storage. Sometimes this is important in terms of cost in cloud, that you want to have dev be the one that is really low scale, low cost, and maybe the production one is the one that you want high performance. So that costs a little bit more, so that maybe that's a difference. But the idea is that this is one way deployment. So if somebody comes along the way, let me draw a person here, and changes the configuration, these scripts would never know about it. So it's not constantly checking. So it's a one-way deployment, what I call, which is, it works very well for some use cases. I'm not saying that it's bad, but I'm just trying to explain how it actually works. For the next one is, I call this one pull and reconcile. So this is the aspect of GitOps. So this is a similar way. You declare in source version control the configurations for the different environments, the version of the software that you build. So in Kubernetes and Openshift, it could be the version of the image of the software that you want to deploy. It could be software that you develop in-house, or it could be software that you take from open source or from a vendor, and that's the software that you want to deploy. So you would declare that in source version control, for example, Git, but it could be another one, and then GitOps would detect that this is the desired state. This is the desired state, and then it will deploy. So it's similar to the one of push. The aspect it is in a certain amount of time, this controller, this GitOps controller, will go back to the different environments and compare if they're equal or not. So they will compare the desired state, and if they're not equal, it will make them equal. So if something is missing in an environment because somebody removed something, it will add it. If you, and this is the other aspect that I like about GitOps, if there's a configuration or something that you deleted, so for example, a config map that you deleted, or a secret that you deleted, and you deleted that from the configuration, GitOps will make sure that it's also deleted from the environments, because it's always checking that those two environments are equal. And it's kind of the same way that Kubernetes works. Is the only difference is the database here is a Git database in source version control, than the desired state is the other database in your cloud provider. Let me see if there's any questions so far. There's no questions. I'm giving a very high level view for this is an introduction aspects of it, but it's good to have the fundamentals before go deeper into it, and also the difference between what I call push, what they call push independent, or push and forget, versus pull and reconcile. So that way, if you deploy software today and next week you are wondering if the software is still configured the same way that you left it the previous week, you know that it's that somebody's watching, always watching that make sure that state matches the one in Git, and it's not a push and forget. Another way, going deeper into, I try to avoid calling tools, but going deeper into actual tools. So this is another view of the same concept, where you have on the left side the system of collaboration. So we humans use source version control, in our case Git, as a way we collaborate. So things like GitHub and GitLab have become, Bitbucket have become very famous of collaboration with software, because it's also useful for having issues or tickets, having change requests or pull requests, conversations, discussions on what the software should be compiling or doing. But in terms of operations or infrastructure as code, this system can also work for administrators to talk about how to configure the system, how to deploy the software, and that system can also be used for collaboration. So if we, at the end of the day, if we have different teams, development and operations working together, maybe the best way is to collaborate on the same system on using Git. So in that case, the way Git works is Git has an API. Usually you use a GUI or CLI, so you would be doing Git push as you make changes into source version control. Those changes goes into the Git database. In the other aspect, if you want to interact with the runtime, if you're working with Openshift or Kubernetes and you're learning that, they have a tool, and it's the CLI, the command line interface. Very useful for getting started, to try things, to configure things, to configure your development environment, or you're configuring Kubernetes in your laptop and starting from scratch. It's very useful. I use it every day. But when you go into production, or you go to a high-scale system or an enterprise system, then you cannot have humans working like this, because Somebody could be changing the system today, and somebody comes the next day and start changing the system. And what's happening is, as people configure or change the configuration of the, I call this one kind of the cloud, they use an API. So they were using the Openshift or Kubernetes API. So every person will be like making changes through the API, and those changes go into the database of Kubernetes. Typically, it's called etcd, but there's other implementations. K3s has a different implementation called Kind, and they use SQL. But for the most part, this database is a key value store that stores the desired state for that environment, that cloud applications. But the problem is, like I said, if somebody configures this with that configuration, then you're using the system that is not optimized for collaboration. So it's better to not use this, and it's preferred to use Git as a way of declaring, for the humans to declare and collaborate what is the environment, how many environments, how many configurations you want. Use Git or the CLI or the GUI to do that, and then go through the database and then let the GitOps controller synchronize the information that is stored in the database of Git to the information that needs to be in etcd. So sometimes at the end of the day, that's what I tell people, that it's GitOps is synchronizing this database with this database. So sometimes folks get confused because they think that we're just moving the problem from here to over here, so we still have the problem. And actually, that's kind of true, right? So if you do something malicious or something wrong, or configure something incorrectly, you can do it here, but you can also do it here, and that will propagate over here. But the idea is to have a user experience of collaboration using Git to use source version control, to have the collaboration there that is more exposed, more user-friendly for people to see what is the state. The same way source version control on GitHub showed you like all the files, has a GUI, a web UI. Then you have that experience in here, and it's better for the humans to do that. And not saying that humans have to be the ones configuring this. Then you go to the next level, having automation and having tools to configure what is the content of this GitOps repo. And then that will control there. But at the end of the day, is whatever gets added here or deleted here, it will happen here. Let me see how we're doing with time. So let's go and see the demo. So if you're still awake, put something in the chat. If you want a demo, put the word demo. If you don't want a demo, put something else. Let me see. I see a hello. I see a demo. Okay. Okay. So let's talk about a little bit about demo. So this is my computer here. And what I have here running is I installed the Openshift. I have basically Kubernetes running my computer. So it comes on the Mac, comes now with a GUI here that you can start the Kubernetes cluster, stop it, delete it, and then I can log into the console. So this is Openshift running in my computer. It takes a lot of memory and CPU. So if you have a small laptop or you don't have a lot of resources, I would not recommend to use this. But I have links in the slides where you can get a free cluster, Openshift cluster on IBM Cloud on this link, and then you can start a cluster. So I also have a cluster on IBM Cloud, but I'm going to show the process of what I did basically last night. So I have this cluster, it's Openshift, but it's Kubernetes, and I wanted to deploy an application in here. And sometimes you can start from the console and deploy something in the console. But like I said, if you deploy something directly on using the GUI or the CLI, it's good to get started. It's good to do development, to get things working. Once you have something that you want to configure, then you want to do it with automation. So our challenge for today is I want to deploy, these are my requirements. I'm going to be using Openshift. Let me see, I'm here. I'm going to use Openshift, and I'm going to install a few operators. I want to deploy an application. Is the service mesh Istio application. It's the book info, book reviews application. It's a microservices application composed of different. Let me put this out of the way. So I will need a few operators. Argo CD is the OpenShift GitOps operator. Is the open source technology behind it. Argo CD is something that implements GitOps. There's other open source tools like Fleet or Flux CD. I'm going to use Argo CD since it's native to Red Hat OpenShift, and if I'm going to use it for enterprise, I get support from them. And then I will install the service mesh operator, which basically it needs other operators: Istio, Jaeger, Kiali, Elastic, and then there's time where I'm going to show still secrets on how to do secrets with GitOps. And I'm going to deploy a application called the book info. So what I did here was I went, and it's kind of the chicken and the egg. I was going to configure Argo CD inside the OpenShift cluster. So basically what I did there was went to the operators, operator hub, and installed the GitOps operator like this. When we do it with automation, basically when we deploy the OpenShift cluster with something like Terraform or the OpenShift installer or Ansible, the way that we do it for enterprise and customers is we deploy the cluster and we install Argo CD, OpenShift GitOps, and then configure Argo CD to connect back to a Git repo. So I already installed this one, and that's the only thing that I did manually because I did it on my laptop. I didn't do the full automation with Terraform. But once I did that, I connected. I have a repo that I created, and this is the repo for the demo today, which I can show here. And I have this is a framework I'm doing. So maybe if I can show this in VS Code, actually how I use it. So here's my text editor. And is this dark thing looks okay and the size, or should I make it bigger? Bigger? How about that? Okay, good. So I have an empty cluster out there. I have Argo, and basically what I'm going to do is I want to configure a Git repo, a Git repository that I can give to, let's say, Sean or Brian, that they can take this Git repo and take an empty cluster and point to it and then let their hands off, and the thing will be configured from the namespaces, the cluster roles, the operators, the instance of the operators, the app in different stages, everything from Git. If we want to change something, we go and change it into Git. So this is my Git repo, and and this is where it comes where how you want to work in Git. So we're trying to come up with a convention of that we have different teams. We have people that work with the infrastructure. So these are the people that configure the cluster or cluster admins, and maybe these are the person that have access to create namespaces and cluster roles. So what I have here is I created some Argo apps, and we have a framework where the GitOps starts empty, and then these files, these YAML files, and I surrendered to YAML. So in Kubernetes, we use YAML for everything. So basically, I moved the files from inactive to active. And what this is doing is I have some Argo apps in Bootstrap that is watching this folder. So I have the same thing, active, inactive. But basically what I did was I moved these files from inactive to active. And then these are the files that it's going to create the namespaces, basically. So this is why we have it under infra, because those are the folks that have higher permissions. So if we look at one of these YAMLs, this is Argo CD. This is an Argo CD resource telling Argo CD, please deploy the things that you find in this Git repo. So in this case, let's look at the dev. I want to create a namespace called dev. So I create an application, and I want to point to a Git repo. So in this case, I'm not pointing to this Git repo. I'm pointing to a Git repo that we are using for a project that we have in IBM that I'm working on. That is called the Cloud Native Toolkit, and it has already these things out of the box, so I don't have to do much. So I point to there, and this is the Git repo that I want to use, and it will find there the YAMLs that defines the namespaces. So I basically, all of this, if I want to deploy istio operator, this would deploy the namespaces. So this will take care of it. So if I move this over here, you will see the Argo apps, Argo start creating namespaces. So I don't create namespaces by hand. The next one is actually installing Istio or Service Mesh. And then this is an example of inactive and active. So I have things inactive, so I can install other things like SonarQube, Swagger Editor, other operators, but I don't have them in here. So I have them in the inactive folder operators also. So let's look at the active. I moved a few files from there. So I wanted to install the Service Mesh operator. So this is another one, Argo CD application that points to a Git repo, Git repository, which is the multi-tenancy repo that already has the snippet of YAML to install the operator. The Service Mesh depends on Elasticsearch. So I have the same thing. All they look identical. The only thing that is different is I'm pointing to this folder. So operator Elasticsearch. For Jaeger, it says operator Jaeger, Kiali. So basically, these are like, I'm configuring Argo, telling it, configure me or deploy me namespaces, configure me or deploy me operators. So I need Kiali, which is part of Istio and Service Mesh. And then seal secrets. Something that I may show at the end is, how do I put secrets on Git without exposing my information? Meaning that I want to encrypt the secret, put it in Git, and then let the cluster decrypt it and create me the secret. But I created the operators, and then if you have seen some talks on operators, you need the instance for the operator to work on. So for Istio, I need a Service Mesh instance. And again, that's another Argo apps. So mostly what you will find in this repo is Argo applications, but they point to a central location where all the things are defined like a library. So I moved those files from inactive to active. And then the apps is where I want to deploy the book info. And then in the book info, so let me stop there and show you in the cluster where those things are. So I created the operators, and basically what is happening now, if I go to the operators and I go to install operators, you can see here I have Elasticsearch. This is very small, I think. I have Elasticsearch, I have Jaeger, I have the Kiali operator. GitOps operator is the one I first installed by hand, and the Service Mesh operator. If I need to do this, multiple times for multiple clients or on my own cluster, I will forget what is the order, what depends on what, and basically what we're delegating is this to the collaboration of using Git to declare the state that I want to in the cluster. So I did that, and then Argo is deploying here. If I bring up Argo CD, which is the Openshift GitOps, you can see here the different applications. So for the operators, if I look for the services here, I know this is very small. You will see that I have Jaeger, Kiali. So this is just a GUI showing you that is watching over the namespace and deploying the this one. So this is Elasticsearch being deployed, and that's the operator. Now we have the operators, we have namespaces. So if I go to projects, I will see the namespaces that I wanted to create. Dev, prod, I created prod, I created staging. So that was infra 3, shared services. Staging is here. So I have my namespaces and I have an operator, I have Service Mesh, configure, up and running, Istio. So now I want to deploy the application, the book info application. And if we go to apps, in apps, I have, again, an Argo CD folder. And these are just conventions that I come with to make it easy to follow along for people to pick up. So it's a matter of like giving this repo to someone, and then they can move files from inactive to active. and that's basically the end of the story of how do you deploy things. So what I did was I moved things to the.
I found this on the web for the end of the story of how do you deploy things.
I think Siri's waking up. So I have dev. So this is an Argo CD application, and I have prod, and I have staging. And then this one is not pointing to that library that I mentioned. It's pointing to actually the application that I want to deploy. So this is, I'm reusing the same GitHub repo. Usually you use a different one. You can use a different GitHub repo. So probably what I'm going to do today is I move this folder, the book info folder, to a different GitHub repo. That way it can be reusable. But again, like I said, we're sometimes we need to be careful how do we distribute all this work, because then it becomes complex to understand. We try to optimize it. So we are moving from a complex system working with Kubernetes to a complex system working with Git repos. And then how many Git repos do we have? Who have access to the Git repo? Who can change it? Who can do PRs? And that at the end of the day, that's better collaboration tool than using Kubernetes as a collaboration tool. So I have my Argo CDs, and then what is this thing is deploying? So if I'm going to look at the dev, it's going to deploy this folder, apps, booking for base. And on this repo, which happens to be the same one, which happens to be, make it a little bit bigger, book info here. And I'm using Customize. So you can use tools like Customize, Helm, Argo CD supports this, Flux CD support this. So it's a way of you are templating your YAML files in Kubernetes. So in this case, I'm going to deploy a few things for this application. I need service accounts. So I have, this application is kind of an example of Istio. It's I think it's three services, microservices, working together to create a book info application. So we have details. So details is something that will have a deployment, a service account, and a service. So those three things. So for each one, I have to deploy those three things. So as you can see, for one microservice with one database, this is overkill. But where I work usually is I work with enterprises that are running airlines or enterprises that are working car rental companies. And they have, hundreds of developers and operators and hundreds of different environments on premise, on cloud, for staging, for production. And having this in a system that you can optimize is kind of a good solution for that case. But like I said, it depends is what you're working on. So in this case, I have service accounts. This is customized. You can go to customize.io, learn a little bit of customize, but at the end of the day, I'm declaring the YAML files, putting them in Git. This is the service accounts for the three microservices. For details, for product page, becomes kind of boring, but it's how you configure Kubernetes. I need the deployments for each one of them. So I have a deployment that points to the version of the software that I want to deploy. In this case, if I look for the image, it's a ready image that maybe you have CI, like Tecton or Jenkins, building that image, securing that image, signing that image. And what we're doing here is continuous deployment, working with GitOps. So I have the same thing for deployments. I have services. So I have the services defined for the four microservices. And then I have some service mesh aspects of it, like a virtual service and a gateway. So these are like Istio YAML files. So as you can see, if you don't put this in Git to organize, to work with somebody else, if somebody makes a typo, everything's in Git. So you can make pull requests, open issues, and it's in Git. So, and then we have the customization, which is the customized file that says, please deploy me all these YAML files. And basically what it's going to do, the GitOps operator is it's going to compare the desired state of all these YAML files to the ones that are configured in the cluster. So if something is not configured in the cluster matching what is in Git, it will get deleted, it will get updated, or will get added. And this is how we're going to deploy. We want to deploy base into dev. The overlays is something that we use in Customize to say, in production or staging, maybe I want more replicas because I need more horsepower or I need more performance. So you will create staging, and you create a customization file, and you say, I want everything from base, and I want to patch something. So you will have your patch in here. In case I did an example, like the details application should have 2 replicas instead of 2, 2 instead of 1. This is a kind of a manual way of doing scaling, and better ways horizontal parallel scaler, but I'm just showing it as a illustration. And then for production, it's going to be the same application, but a little bit slightly different. The same thing. I want base, and I'm going to patch details, and I want three replicas. So I need like even more horsepower for production. And this is kind of the book info that I'm going to deploy with the 3 Argo apps. So I have an Argo app for prod, and I have Argo app for staging, each one pointing to that folder in Git. And basically, I set up this GitHub repo. In your case, if you're not the one that know these aspects, somebody can do it for you. So I did it, and then I did it last night. So I went ahead and configured the cluster. And if I go to, this is the one in my computer, and I go, for example, to, let's go to dev. You will want to see the application in dev. If I go to dev, I see the application being deployed here with all the microservices. In this case, there's a reviews 2, reviews 3, reviews 1, because to show traffic splitting, but the application is running in dev. If I go to prod, where is prod? Let me see here. Production or staging, which is the next one. Staging. I will see the same application, but remember that details should have more pods. So in this case, it has 2 pods. And if I go to production, and in this case, I'm doing everything in one cluster. In enterprises, usually you have different clusters, you have different regions, so production could be a totally different product. It works the same way, pointing to Git for that environment. And then prod details should have 3 replicas. And basically what's happening is that GitOps controller, in case Argo CD is an open source application, is watching over all these things. And for example, if I go, maybe here, I want to go to the namespace, what's being deployed into prod. I can go to prod, and the only thing that is running in prod is a namespace, whoever's creating a namespace, and then the application. So this is the resources from Git. So if I've changed something in Git, this should be reflected here. So for example, this is prod, is refreshing, and details should have 3 replicas. This is prod. So if I want to change something, for example, see here, prod has 1, 2, and 3. If I want to have 4 replicas, so I want to change something about the application, the only thing that I need to do is go to Git, go to the apps, find the book info. In case I'm doing it in this repo, like I said, it should be another repo. I can go to prod details, and maybe I want to move this to 4 replicas. I save it, and then I do a pull request. Somebody will review it, or I do a pull request. It gets tested, that nothing happens. In my case, because we're demoware, we can just push it directly.
Sorry, I'm having trouble hearing you.
I'm not talking to Siri. Siri keeps talking here. So I can just push the change. So I want to say, and this is like a pull request that somebody will review, or it gets tested with automation, and maybe if it works, it gets auto merge, and then we have production. We work 4 replicas. So this is kind of the pinnacle of like continuous deployment, continuous delivery. That software gets updated, gets validated, it gets promoted, and then it gets reconciled. And reconcile is the key aspect of GitOps, and that's basically what you want to care. So we want to make this change. I can say, Carlos giving a demo prod to 4, right? And I can do this and just merge it to main. I didn't do a pull request, but if you follow the process, that will be the change. And then in a few minutes, if I have the GitHub set up to point to my laptop, it will refresh, but I can just hit refresh here, and then the controller will detect there's something out of sync what is configured in the cluster doesn't match what is in Git. What's going on? Let's start syncing. And it starts comparing everything. It starts comparing the things that change. And it found that details is not matching what is in the cluster. So it needs to be, it needs to match. So now instead of 1, 2, 3 replicas, we should be deploying a new pod, and a new replica should come up. So now I see 4 in here. So if somebody makes a mistake and it goes to the cluster and wants to be, see here, we should have 4 pods. And even if I delete one, but that's the deployment will take care of that. I can delete the deployment if I want. I can go ahead and delete the deployment. Maybe I made a mistake because I meant to delete the deployment from dev, and I made a mistake, and I didn't notice that I was in prod here. I should have done it in dev. That's the sort of thing that happens when you give access to folks in your cluster, right? But in this case, I really don't care because Argo will detect that the deployment is missing and start deploying again. So as you can see, it got deployed again. So this brings reliance and robustness into the deployment. So I have a few minutes. Let me show the last thing. I didn't get to the secrets, but we can do a session 2. So what I did was I went to this website called, this is a website that you can get a free cluster. I think it's for a full day or 8 hours, and you can play with Kubernetes. You can also get 200 credits in IBM Cloud and get just a regular Kubernetes Community Edition. All the things that I show here are open source technologies, cloud native technology from CNCF, and the practices is something that we are advocating. So you can use Openshift for Kubernetes. What I did this morning was I launched one of my clusters here. I use my lab number 6, or this lab, bring your own application. Basically, I got a free cluster. It has a few hours left. If I can find it here in my, well, I can just launch it here. Let's see if it launches. This is the experience that you will get. You get a terminal. On this one, I have 1.5 hours. I can bump how many hours I want. So I wanted for 4 hours to do more exercises and learn. So I now have 5 hours left on this cluster, and I can launch it. So what I did this morning was to test actually the thing that I was going to show that if it actually works. What I did was I deployed this cluster in IBM Cloud. As you can see here, this is a domain name that you get from IBM Cloud. And basically I went operators, operator hub, the same process that I did. I typed GitOps or Argo. If you're using just Kubernetes regular edition, just use kubectl from the Argo instructions and install Argo. I went install Argo and basically step away. And then what I did was I went to the login, and I went and I did the bootstrap. And I did a kubectl apply or OC apply into this bootstrap. And then this bootstrap was the first Argo CD application that started detecting the other Argo CD applications. So this bootstrap basically points to Argo CD active, which points to this folder, and it found an Argo CD application for all the apps folder, the services for the things in the services folder, and the infra for the infra folder. And basically with one command that I did to just install this one YAML, I just installed one YAML, then everything started deploying on that cluster. So if I open the Argo CD here, this is the cluster on IBM Cloud. I believe it's in Dallas, Texas. And I got the same environment. Everything got deployed in that cluster. All the operators got installed, they got configured, the operands got configured. If I go to the developer console, see it's the new, this is still running, it still got deployed. If I go to prod, I just see, and since they're connected to the same Git repo, I put 4 replicas. This one is following that one. So let's see, we have 4 replicas here, and we have 4 replicas. So I'm configuring 2 clusters with 1 Git repo. That's also so useful if you have like different regions, like the Europe, you have US or East or versus West Coast and East Coast, and you want to deploy the application in 2 regions, so customers or users closest to the region can get, faster, better user experience and have load balancing. So with one Git repo, I was able to configure 2 clusters, but I can configure 1,000 clusters just from Git by having every cluster get configured automatically, putting the information in. And lastly, if you want to see the application in Istio, you have to go to the Ingress Gateway. I didn't do like the DNS like carlos.com, but let me show you here how that works. If you go to, actually, I think I have it, the book info somewhere here, one of these repos. So yeah, so this is the application. It's not, it's the Istio book info, which is also an example that comes with the Openshift service mesh. And basically, every time you refresh, you are like rotating over the different versions of the review. So you get V1, V2, V3. If I refresh again, you get the ones with the stars, you get the one with the black stars, and then you get the one with no stars. And you're like, this is showing like how Istio and Service Mesh you're doing A/B testing basically to test that you get a different one, but you can do it. So this is the example running on IBM Cloud, and have the same app running in my computer here with CRC testing. So this is URL on my computer, and it's the same app. So that way you have kind of like the 12-factor cloud native configuration where dev, staging, all the environments work the same. The only difference is the configuration, and you do it through Git. Basically, that's the value of GitOps, and why you should care to learn about it, because this is kind of the new way. Not a new way, because a lot of people are using it already, but a lot of people are learning about it. And we created the GitOps working group if you want to join in open source. I think that's it. Comments, questions, Jenna, in the chat that you want to highlight?
Not, I think the earlier
Call me crazy.
answered already.
But other than that, if there's questions, hopefully everything went through the screen share. If not, I'm up to doing a Twitch if somebody wants to join.
So there's a question.
What are the minimum system requirements to run Argo? To run Argo is very small. So if we go to Argo is written in Go, and it's very small addition. So let me see if I can go to the cluster and show it's installed in Open GitOps namespace, and we should see the things that are running for Argo. And if you want to see like this is this deployment. See, in terms of CPU is 0.07, 0.002, which is nothing, 0.002, which is nothing, 0.001 is nothing. So less than 1 CPU I'm using here, and 5 megs, 34 megs, 8 megs. I don't know why this is asking for 2 gigs. You can change it to use less. I bet it's using less than that. We can do monitoring in here. Actually, yeah, you can do monitoring here and see how's the memory usage. So, it looks like I'm using 2 gigs. Yeah. So in larger enterprises, 2 gig is like nothing, right? You have multiple nodes, each one having 16 gigs, usually, or 64 gigs. So this is a very small amount of work. Also, you can run Argo in one cluster and do not have to run Argo in every cluster. So basically, your Argo does the work of deploying to remote clusters. So you wouldn't have anything. You pay the penalty of only having one Argo for multiple clusters. You don't have to install Argo on all the clusters. But I prefer to have Argo on every cluster, so it's like self manage. Any questions? Argo CDs written in Go, less than 1 CPU. I think, yeah, Jenna pointed it out there. Yep, but Jenna answered the same thing I said. Any more questions? Like I said, this was a very high-level introduction, but also showing some of the concepts and lessons learned that I have done for working with Argo for the last, I think, 2 years or 1 year. So do not use a VM for this at all? I'm using OpenShift on my laptop, and essentially that's using a VM behind the scenes using HyperKit, and it requires a lot of resources. But you can do the same thing with Kubernetes using Docker Desktop, comes with Kubernetes kind. If you really want to run something in your laptop, I usually find it that it's easy these days to find a Kubernetes cluster on a cloud, on any cloud, IBM cloud or another cloud. In IBM, you get $200 credit. If you put a credit card, you get a free one node Kubernetes cluster. It's about 4 CPUs. That's good for learning. Also, what I show with OpenShift, the OpenShift labs that I show, these are free labs that you can use for a day for learning. But for running something in production, right, you have to get something that is stable, is up 24/7. But yeah, OpenShift. I'm using a Mac, and everything that we're showing here is like Linux containers. So there's a VM running behind the scenes, but I don't have to manage it or anything. Using OpenShift for the demo, but you can use Kubernetes on any. Yeah, Jenna is answering. Yeah, with the 200 credit. And like I said, if you put a credit card, I've done it with my personal accounts, and when I teach, you put a credit card, you don't get charged, but you can get a free Kubernetes cluster. I think for 30 days, and it gets deleted, and then you can create a new one. And that's a one node cluster that is very useful for learning also, or trying things out. If not, like based on demand, we OpenShift in IBM Cloud, we support by the hour, hourly metering, so you can OpenShift or Kubernetes by the hour. So if you want to run something for X amount of time, you can run it and then shut it down and run it again. And the thing behind this talk is like, if you create a cluster from scratch tomorrow, just point it to your Git repo and the thing gets deployed in 5 minutes. Or somebody deletes your cluster by mistake, thinking that they're working on a different account. That happened to me. I said, fine, I'll create a new cluster pointing to Git, and I have the cluster up and running in no time because I'm using GitOps. So I'm not afraid of losing clusters. I'm afraid of losing databases. That's why I don't know databases on OpenShift. But other than that, if you have data redundancy, I have snapshots and volumes and backups, I should not be a problem. The stateless microservices just get deployed again. All the configuration gets deployed again from Git, as pointing to, like I showed, pointing to a Git repo. Can OpenShift latest manage only one Kubernetes cluster and one? I heard future Open can manage multiple Kubernetes clusters too. I don't understand the question. OpenShift itself is a cluster, so it's not managing other clusters. There's Red Hat Advanced Cluster Management, which I also have a Git repo that shows how to manage multiple clusters in different clouds and have policies. But in terms of managing only one cluster, I don't understand the question. You can manage as many clusters you want from IBM Cloud or from Red Hat Advanced Cluster Management. And looks like we're finishing up. Jenna is putting the feedback survey. If you like this talk, go ahead and enter the survey. If you hated this talk, please do not do the survey, I guess. I think that's all, folks. So say your goodbyes and do the survey, right, Jenna? We're done. think we're past a little bit of time.
Yep. Yeah. If anyone has any questions, they can go ahead and stick them in the chat.
If you're
We'll wrap
speaking,
it
Jenna, I
up
don't
here.
hear you.
Oh, just 1 second.
And
Sean?
as a reminder, we will share a link to this
Eva,
presentation.
thank you. And
as
you
soon
can
as the
follow me on
event
Twitter.
ends.
And then you can ask questions there. I also run a Kubernetes book club. If you want to learn about running Kubernetes in production, I run a book club. You can find out in my Twitter.
Are you able to hear me now?
Yes, we can hear you.
Okay.
Yeah.
Just having
Jenna's
some
putting
issues.
the GitOps survey there.
Yes.
So yeah, and we'll get the link to the book club, and we'll make sure that we share that in the post-event email
Thank you.
that we
This was
send
great
out.
intro. Yeah. I intended to make it very,
the
very
link
simple
to the
for
presentation.
first time people seeing this stuff. Do not
Interesting
be
content.
afraid.
Thank you, Carlos. Alrighty, thanks everyone for joining us today.
John, Yasmin, Lecha, Stacy, Tavich, and Cole. Thank you for all being here live. You're brave people. Please share the video link. Yes, it'll be recorded in Crowdcast with the other talks. Casey, thank you. Yeah, thank you for being here. Jeremy, thank you.
1 sec. Of course.
And Siri is always with us.
Siri says thank you too. Alrighty, bye folks.